Hello. Hello. Good morning. Do that. Hmm. Let's see here. It's the 28th. This will be our I want some notes. All right. So today we need to talk about a few things. One is objects. And this. Yeah, okay. my wallpaper. Does anyone know what that is? Yeah. I did that on purpose a little bit. That's Deborah, yeah. This is our joke, huh? This is our joke. Since I upload these to YouTube, one day someone named Deborah is actually going to see this and she's going to be upset. Maybe. I could do something like that. I did, one of the assignments my students did, the final project, was simulating 2 restaurants. Maybe Deborah could be a customer in one of the restaurants. Okay, it's 11:30, so we're gonna get started. I don't have my Chrome open for obvious reasons. Someone posted a funny meme about that the other day. All my RAM going to Chrome. That's correct. I also posted a link in the Discord to a long article. If you're like me, you don't like reading articles, but the point I was making was that there was Chrome had a dangling pointer in it. So that was kind of my little like proof of concept to you to say, hey, these things happen and they can cause problems. So for all I know, the dangling pointer was what caused my problem. Code grade when I forget to add my name. We can all work for Google now, as long as you don't make dangling pointers. Okay, let's get rid of the face here. We'll take that away. And then I gotta bring some stuff over here. Don't mind my scary C code from one of my classes. I'll close it in a moment. Just getting set up for today. Now, we are going to talk about a few things today. I kind of wrote them down here. So we're going to do... First thing we'll talk about is the rotation, just because. And then we're going to talk about using objects and pointers. We have about 2 more days of like getting to know pointers. And then for the rest of the semester, we'll continue to use them, though they won't be our subject. Okay? So about 2 more days of those. Today, I'll clean up some assignment 3 stuff. I believe assignment 3 is not due until tomorrow. So you'll have some time to go revisit some of the stuff that I talked about today. Though a lot of you have gotten a lot of progress on it. I'm very happy about that. But I do know some people are panicking. Maybe not panicking. Yes, I meant assignment 4. I'm sorry if that's not what I said. I meant assignment 4 is due tomorrow, I think. And maybe you're not panicking, but you're probably getting seg faults, or your grid is not coming up with anything, some stuff like that. So we'll talk about that today. Now, the first thing I said I was going to talk about is the rotation. Now, the rotation we're doing in this assignment is not like a standard rotation, meaning not everyone will always move. Now, the reason for this is because, for one, an actual rotation algorithm is kind of hard to write unless you want to go around the grid and just swap everyone once, meaning that someone will be swapped around the entire grid completely. And that will work, but that's not what I want for this assignment. I want you to simulate actually moving the pointers between spaces. So if you got the program working already with some swapping thing, as long as there's no memory leaks, you're going to have no issues. I won't mark you down or anything. But I do want you, if you haven't gotten to it yet, to simulate the people moving through the spaces. So let's talk about that. And to do that, I'm just going to make a little Excel sheet as I usually do. So our grid in the assignment, I'm going to make a smaller one, okay? The one in the assignment is 11 long. This is just a small little example, and this one shouldn't be here. Now in here you'll have your chairs. That's where the chairs go, usually. And then around, you're going to have the people. And so not everyone will always move. And only certain things move at certain times. So instead of like simulating everyone doing it at once, the top row will move, and then the left column, and then the bottom row, and then the right column. So if you're going to have 1, 2, 3, 4, 5 here, say you have 3, 2, not 2, I don't know, 7. And then here, I don't know, we'll put maybe an 11, 13, 14, and a 15, and something like that. So these are completely off limits. You're not going to look at these at all. And so the first thing you're going to do is start from these two, and you're going to try to shift everyone left. So the simulation here is... so yeah, Cade says, I noticed in the video that they don't end up in the first and last columns. Now we'll talk about that. That's why we're going to talk about it, right? Because it's not an actual rotation. It's like a semi-rotation. So the reason no one will ever end up here, but someone may end up here. So I'll kind of highlight these just a little bit. You will never see anyone in these cells. Pretty sure. You should never see anyone in those cells. And here's why. So the first thing that happens is everyone up here gets shifted left. Now you're going to pretend like person 1 is going to try to move to person 3. So you might call get person here. And then you might call stand person over here. Now this stand person function returns a bool. Okay, it's going to say I was successful or I was not successful. Successful. So if you're not successful, then 1 will not be stored there and you can stand them back in the original spot. So 1 will try to move here and they're going to see that 3 is here, so 1 bumps into 3. Doesn't work. So then 2 tries to move here, bumps into 1, doesn't work. 3 tries to go here, bumps into 2, doesn't work. 4 tries to go here, bumps into 3, it doesn't work. This is empty space, so there's no shift. And then 5. 5 tries to move here. There's no one there, so 5 will move. I'm now here. So that was the very first shift. All right? So notice, not very many people moved, right? Only 5 did. Now the next one. So this is one for loop, by the way. One for loop for this. Now we're going to do a for loop for this one. 3 will try to move here. Actually, you're right. It depends, Cade. I just proved myself wrong. I think 3 will end up... actually, no. I'm not wrong. I'm right. So, everyone will shift down, meaning you're going to start from these two here. You're going to start from these two. So, kind of in the direction you're moving. In this case, everyone's moving left, so you're going to start at the leftmost. In this case, everyone's moving down, so you're going to start at the bottommost. So 7 tries to move here. There's no one here, right? So 7 moves. Now 3 tries to move here. 3 can do it, so 3 moves. So far, I hope it's making sense. So now, we're going to shift everyone right. Okay? We're going to shift everyone right. Now, we're going to start from the rightmost here. We're going to start from the rightmost. So in the rightmost case, we're going to try to move 15 to 14. It can't do it. Nothing happens here. 13 moves here. Nothing happens. 11 moves here because there's nobody there. And then 7 will move here. Now check this out. There is a case where someone might get stuck here. There's a case that someone might get stuck here, but I'll give you one more example as to why we don't see that in the assignment. And then finally we do this one, right? So nothing happens here, but then 14 moves up. And that's that. And then the rotation's done. That's it. Nothing more happens. So now I'm going to give you one more example. This one is how your assignment will happen every time. And as Cade said, you'll never see anyone here or here. And I'll show you why that happens. So where does everyone start? Can someone remind me? Where does everyone start? I said it in the assignment, and you can always see it in the picture. Synthos asked, does everyone move one space? Yeah, they do. Turbo says the bottom row, depending on what you call the bottom, they start up here. So person 1 will go here. Person 2 goes here. Person 3, person 4, person 5, person 6. That's where they start. So this 100% of the time is the starting position. This is always the starting position. Class says, is this like bubble sort with pointers? I don't know. I'm sure there's some way you could do it. We're going to get to sorting pointers today or tomorrow or Thursday rather. But what you're saying there's a little bit different than this one. But we're kind of like bubbling people around maybe. So here's why it happens, okay? So no shifts will happen here. None at all. No shifts will happen here at all. Because no one can move. So then and then we go to the column. So 1 comes down. Or, well, what happens here? I've got to check my algorithm. Because the way that it might work here is that 1 will move here, and then 1 will move here, and then that's it. And then they check the right one, and so this one moves here. And then 1, I'll have to check that. I might do it right now. Based on the PDF, I might end up editing the... I'm glad we talked about this. I might end up editing the code grade. I won't make you change your programs. I don't know, unless someone matched it. We'll see. We will see. Let's see. Shift the left column down. So when you move a variable, are you moving it from one address to another, or does that address move with the variable? That's a good question, Lalo. What happens is you're moving the address between pointers. So you're not changing any addresses. One person has their own address. So I get the address 0x00A. I get the address 0x00A. And that's my address for my lifetime. And so my address will just move from pointer to pointer. The address never changes. The address is moving with the variable. It should be noted that there are stars on the left column. Turbo, that's just the border. That's like the game border. It has nothing to do with the spaces. I'm just showing you what the space looks like. It's like a wall. So let's see here. The way we've got it is we start from the leftmost side and we shift everyone over. And then we start at the interesting. Let me revisit this. I may change the code grade. I'm going to check to see how many people have submitted it. And if they matched it, I may just give them the points. But based on my PDF description, I think I've made a small mistake. Maybe I did, maybe I didn't. So let me come back to that, and I'll revisit it. I might make a little bit of a video. I want you to follow the example that I just gave you, so you can watch this video back. The example I just gave you, I want you to follow that, okay? I'm just going to edit my code to match that. I swear I had it that way, but I guess I didn't, so it won't be too big of a problem. Are you guys okay with that? Have I upset anyone greatly? Please let me know. But as far as I'm concerned, I don't think anyone should be too mad. You can let me know if you're angry. I won't mind. So that's going to be the rotation function, the one that I described. So let's just do it real quick. Just real quick, okay? The one that I want you to do. The one I want you to do. So shift everyone left. Starting like this. This is the one and I'm just going to have to edit my little bit here. Everything else in the code grade should match on these ones, but I'm going to edit this little bit. So everyone will shift left. No one can do it. So then we're going to start here. This shift doesn't happen. One will go here. Okay, now we're going to shift everyone down here. Nothing happens. And then we're going to shift everyone up here. Nothing happens. So then we're going to go around again, right? We're going to call the function one more time. What happens? 2 goes here, 3 goes here, 4 goes there, 5 goes there, 6 goes there, nobody's there. And then we're going to start here. 1 goes there, 2 goes there, nothing is here. And then we're going to go down this way. So we're going to start from this most side, I think, right? We're going to start from over here. Nothing happens, nothing happens, nothing happens, nothing happens, nothing happens. 1 goes here. Can you hear me? Or did the stream die? Can you hear me still? Did my face just freeze? The audio was there, kinda. Okay. Well, we're back. I don't know where we got lost, so I'll just do it one more time, and then we're gonna move on. Just gonna do it real quick, one more time. Alright, this is how the rotation will go. No one shifts left. Nothing happens here. And then 1 goes here. And then nothing happens on the bottom row, because there's nobody. And then nothing happens here. So then next, everyone moves over. That's the left shift. And then everyone moves down. 1 will go here, 2 goes there. And that's that. Then we're going to come down here. We're starting from this side. Nothing happens. Nothing, 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 nothing. 1 can move here. Not there, but there. Then we come over here. Nothing happens. So then we call the function again. What happens? 3 moves there, 4, 5, 6, they all shift. Then we move these guys down, 2, 3, and then we move these guys over, if they can move, starting from here, nothing, 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 nothing. 1 comes here, 2 goes there. Okay? So that's the idea of the function, all right? I am going to edit this, and you can come talk to me if you are having issues, okay? Are there any more questions about rotating? I'm glad we talked about it because I obviously made a small mistake. So now we're going to get back into pointers, your favorite thing. Going to get back into pointers, your favorite thing. All right, so I'm going to review briefly. We're not going to talk about what we talked about last week, but we will talk about what we talked about on Thursday. I should rephrase that. We won't talk about what we talked about on Tuesday, but on Thursday we'll talk about that. So I believe we talked, let's see here. Mainly we started talking about pointers, right? So pointers are just variables that hold addresses. They're like your int variables. They're like your string variables. They're just variables, and they hold things. Okay? Now, it's a little confusing because you're kind of one level up now. You're now dealing with the actual address of the variable and not just the variable. So we're kind of a bit of a confusion there. Kind of some confusion there. Recall that pointers have types. The reason they have types is because the operating system, well, the program, the compiler, needs to know how many bytes to dereference, right? We did a nice example of that last time. If it's an int pointer, it will dereference 4 bytes. If it's a character pointer, it will dereference 1 byte. If it's a double pointer, it will dereference 8 bytes. So that's why pointers have types. We use pointers for dynamic variables. Now, we really haven't gotten a good example of that yet, but today we're going to talk, or today and Thursday, we're going to do an example of an array, a dynamic sized array, and you'll see why these are very important. Now, usually when a pointer is declared, or when the pointer is not supposed to have an address, i.e. the dangling pointer, we're going to store null pointer inside. So in your assignment, in the constructor, in the default constructor of the chair and of the space class, you're supposed to initialize the pointers to be null pointer. There's a reason for that, because we want them to be empty. We don't want them to contain some garbage address from the operating system. When does your program segfault? When you deref an address that you're not allowed to, but more often when you deref a null pointer. If you have segfaults in your program, I 100% assure you you're doing this. If you are dereferencing, if you're getting a segfault in your assignment, I swear you have a null pointer dereference somewhere, and I'll give you an example of that today. Now here's the syntax for this, right? If we want to declare a pointer, you need whatever type it is and a star, all right? And remember that it doesn't matter where the star goes. It could go here. Your declaration could look like this, but this is very ugly. Please don't do that. I like to put it there. And as I said, today or Thursday we'll run into an example where I give you the reason why I prefer it this way and not this way, okay? So here's some examples of some pointers. Now, pointers are used for allocating memory, meaning they'll be empty to start, and then we will put an address in there. We'll go to the operating system, we'll say, hey, I need an address for this variable. Please give it to me. So allocating is requesting memory from the operating system. Deallocating is giving that memory back to the operating system. And in order to allocate, we're going to need a pointer, and we're going to need to call new. Okay? We'll do plenty of examples for that today. I guess I should also put to deallocate. We're going to need a pointer. And to kind of further my point, this pointer should, it needs an address. Needs to contain an address. All right? It needs to contain an address in order to do this. In terms of allocating, I would hope that the pointer contains null pointer. If the pointer does not contain null pointer, we might create a memory leak because we're going to overwrite an address. Okay, so to allocate, we need a pointer, and it hopefully contains null pointer, and then we'll call new. To deallocate, we need a pointer, and the pointer needs to have an address in it. And then you call delete. If you call delete on a null pointer, your program will break. Okay? So we talked about that. Let's come down here. Here are the memory functions, right? You can call new. We only did single variables. We're going to do some more of that today, as well as arrays. And you can call delete. You can do single variables, and you can do arrays. Let's say I'll do more of that today. Now, these are the memory problems to look out for. Now, I've been helping some students. I've already seen some memory leaks. And I've seen a little bit of an alias, but you need to watch out for these things, okay? An alias is that two or more variables are looking at the same address. Two or more pointers, rather. This is sometimes bad, but not always. All right. Dangling pointers happen when a pointer contains memory that was deallocated. So to fix this, let's kind of add these. To fix this, assign null pointer to your pointers after calling delete. To fix this, assign one of the pointers to null pointer. And then a memory leak. This happens when an address is overwritten or the program function exit before the address is returned to memory. Okay. To fix this, for every new, you need to have a delete. In kind of broader terms, to fix this, always call delete. It's more so this. For every new, you have to have a delete. Okay, that's how you fix that. For every new, you should have a delete. It's like your brackets. For every open bracket, you need a close bracket. For every new, you need a delete. So that's what we talked about last time. Now, we're going to move on to a few things. The first thing we're going to talk about is objects and pointers. Now, that's what you're working with in your current assignment. The objects we have are the chair object, and we have the space object, right? Yeah, so Chef says, it's okay to use a temp pointer to hold another pointer. We just have to set one to null pointer after. Yes, that's exactly correct. So there's a few functions in your code, right? There's a few functions that we've talked about. Let's see here. There's one function called getPerson, all right? It's a function called getPerson. Using namespace, st. Top Wolf says, and the person object. Yeah, you're right, actually. We're maybe not using space pointers, but we're using person pointers. You're right. So somewhere in here, you have a class. I guess we'll work on that today. And for this class, I guess we'll just start with maybe a container. No. Let's just do our person. Let's actually copy the one from the assignment. What do you say? Since I gave it to you, I don't see any issue why we can't use it. Let's see here. I'm just going to copy that stuff in. so we can keep it all together. Functions go down there, and our class will go up here. Okay? Hopefully you're okay with that. I didn't scare you with my copy pasting, right? You have this code, you can go find it. So say we have a person class, and then we have our stuff here, right? Now, there's something in here where you are tasked with getting the person from some pointer, right? So you're going to have some pointer for the person. Just like any regular pointer we've been dealing with, you can have a pointer for that person. And somewhere, we're going to have some code. Now, we're going to talk about this in just a moment. But you're going to have some code here that does this. Now, before I take note on this, can anyone tell me what this does? This does two things. This does two things. This does one, this does a number 1, and this does a number 2. Can anyone tell me any of what this does? And I'll fill them in. This statement here, it does two things. What's the first one? What's the second one? Forward, backward, however you want to say it. I just want to know if you have any ideas. That does two things. Chef says, allocates enough space for a person? Yes. I would say that's the first thing it does, right? Goes to the OS. Gets memory from OS, right? That's what the new does. This is the new part. Now, Uchu says, creates an object for a person. Giovanni says, hey, I need a new address, right? That's exactly right. So the allocate space, that's the first thing it does. And returns the address. That's exactly right. But Uchu says it also creates a person. So you know what this does? This also calls the person constructor. Did you know that? We didn't talk about that last time. But it does do that. It does two things. This first thing here, it says, give me some memory. The second thing here says, hey, I'm creating a person. I should probably call the constructor. All right, so I'll put that in our notes in just a moment. But that's what's happening. Now, I should probably initialize this. I just want you to practice good things here. Okay, so I'm going to throw that equals null pointer up there because it's good practice. Okay. Now, I'm saying I want you to, like, return this function. So I'm going to write, say, some function here. Let's see. This is going to look a little bit different than the one from your assignment, but it will be mostly the same. And this get person is going to, like I said, it's going to look a little bit different from your assignment, but it's actually going to take the pointer. And now I'm really going to confuse you. And it's going to take it by, reference. Doesn't like that. Let's see. How's that? Are you unhappy with me? There we go. Are you confused yet? Now, what does that mean? That is you're passing a pointer by reference. So not only you get two things here. You get the value in the pointer, which is an address. You also are referencing the original pointer. I am perhaps confused. All right. Does this make sense, though? You're going to get the value in the pointer. So, yeah, Chef asks a great question. I thought pointers would automatically be passed by reference. Now, here's the thing to recall. This, just like any other variable, is a variable. So, here's what you need to consider. The p pointer stores an address, but the p pointer also has an address. In some sense, it has enough memory to store memory. It has enough memory to store an address. Does that make sense? This variable contains an address, but it also has its own address. Are we in like Inception here right now, right? The address has an address. So here's what you need to consider. A pointer is just like any other variable. It means that what does it store? Well, it stores addresses, but where does it put that address? Right? Up here I say I'm going to put null pointer in this I'm going to put null pointer in this variable. Where does the null pointer go? It goes somewhere. We can't just like throw it into space and expect to be able to find it again. There's a box somewhere. There's a box somewhere that holds that address. It kind of looks like this, is what I'd say. It kind of looks like this. This is like your memory. This is like your RAM. All right? Hey. This is like your RAM. And there's just stuff in here. And so let's say this address up here is like 0x00A. And let's say it's your pointer. So this only needs probably maybe a byte, maybe a little bit more. Not sure exactly. But let's say this holds 0x, I don't know. I'm just going to throw something out here. Don't get mad at me if it doesn't look right. We're going to say, hey, this actually stores this address. Give me a width here. Okay, we're going to say that this cell here stores this address. And what does that mean? Well, it means this. It means that this is looking somewhere else in the memory. And let's say this is going to be, I don't know. Say this is going to be maybe, it's an integer. So it's going to look at these 4 bytes here. We'll make them red or something. And here you've got 00000. I don't know, something like that, right? You just got some values in here. Oh, man. You guys make me so happy. All right, let's see here. So Kate said it stores its address as the same address. No. Notice that this pointer is at this location. And this pointer here, or in this, the int is stored here. Whoops. The int is stored over here, but the pointer is stored here. So I hope that answers your question up there, Cade. Giovanni says it has its own address. Probably, I don't know if it's 8 bytes. I don't know how big it is. You can Google that. And it also has the address for the thing it's pointing at. Yes. So this thing might store null pointer too, right? It could store, you would put null pointer inside of this box. Right? You could put null pointer inside this box. But when you do that, it's no longer pointing there. All right? And then Syntho says, in theory, you can make a pointer that holds a pointer. Yes, you can. And we will talk about that on Thursday. Do you know how you make multi-dimensional arrays in C++? I'll show you. This and this can hold 1D arrays. I'm kind of sidetracking here, but I'm just letting you know. This and this can hold 2D arrays. This and this can hold 3D arrays. And so on and so forth. I'm going to come back around to this. Don't be scared. What is this? This is a pointer to a pointer to a pointer to a pointer to an int. This is a pointer to an int. This is a pointer to an int pointer. This is a pointer to a pointer to an int pointer. This is a pointer to a pointer to a pointer to an int pointer. Okay? So, bring it all back to where we started. Do you understand that when I say this, I'm passing, when I'm passing a pointer by reference, not only am I passing what was stored in the pointer, which is an address, but I'm also passing the original pointer. All right, so just know you can do that. All right, just know you can do that. Anyway, back to your assignment. What this function should do is update the original pointer to be empty, but it also needs to return the address that was stored there. Okay? So to do that, what's wrong with this? Someone tell me, what's wrong with this? Why does that not work? Fuzzy says, hypothetically, could we fill our RAM with pointers to pointers to pointers, eventually tune it? Yeah. It's, calculus. The first calculus you learn is in 2 dimensions, but then calculus 3 is in 3 dimensions, and then calculus goes on to the nth dimension. You can do pointers to the nth dimension. Chef says, should we use a temp pointer, right? We don't want to return a null pointer. That's what happens, right? It returns nothing. Now, what's wrong with this? Why doesn't this work? Why does that not work? Why does that not work? What happens there? How are we doing on that? We're doing okay. Well, nothing happens. Nothing happens after here. And you could put anything down here. You could dereference a null pointer. You could say cout dereference null pointer. This causes a seg fault, but guess what? It will never happen. Why? Because we returned here. Nothing happens. I don't know why you're angry at me. Did I do? Yeah. I don't know why it's mad at me. Doesn't matter. Nothing happens after this, okay? Nothing. So this does not work. So, what do? Well, you say, hey, I need to do this. I need a temp pointer. Int, or person, temp. I say, hey, you're equal to my pointer. And then what do you say? I made an alias. How dare I? I can't believe I made an alias. I am so terrible. Wait, I can fix this. This removes the alias. Okay? I made an alias. I removed it. So I moved, kind of in memory. Let's see, I've got another pointer over here somewhere. I'm sorry if I did my math wrong. I'm once again, don't get mad at me. Let's pretend this is B, C, okay, this is D. Okay? I basically said, hey, put that, I'll do a copy. First we do that, and then guess what? We've got the alias, right? What does the alias look like? Well, it looks like this. And then I say, hey, let's set that to null pointer. And then we remove this error. Alias gone. Crisis averted. Okay? So does that make sense? That's kind of an alias, right? I think Chef had asked that question. We're allowed to do this. In fact, it's required. It is required. Okay? So then if I call, hey, this is just kind of for fun. But I say, this is not necessarily a new person, but this might be p pointer 2. I can say it's equal to get person on the p pointer. And that should set this one back to null pointer. All right, that should set That should set the P pointer back to null pointer there. Okay? So that's an alias, right? Now we kind of made some strides here. Look, we've got a class up here. Man, we've got a class. I'm so happy. We're doing great things here. So let me do this. I want to put it somewhere where it belongs. And I would like to do this. All right. So, we talked about that. So now we're going to actually talk about using pointers and objects, right? So let's kind of move down here a little bit. So now, let's say, hey, I'm going to call getID from this pointer, right? You're required to do this in your assignment quite a few times. You say, hey, I need to get the ID from the person. Why can't I just do this? This will cause a potential seg fault. Why? Why is this not okay? This is almost okay. It's almost okay, but it might not be. And we have to consider something about it. Why is this not okay? In fact, I bet this will seg fault. Let's do it. I'm going to take care of my memory leak, and let's go make the seg fault, shall we? Why not? Yeah, and Giovanni got it, right? Let's go test it out. Hopefully, I'm in a good spot here. Because P-pointer could be null, right? P-pointer could be null. That's exactly right. That's exactly right. All right, let's see where we're at. Where are we here? Boom. Let's see what scary stuff I have. GCC. Man. You guys don't know what that is. And then we're going to need obj.cpp. Compiles just fine. Let's run it. Oh, God. It seg faulted. Why? Well, as everyone said, P-pointer could be null pointer. Now, we didn't talk about this, so let me go into the notes here and just get some ideas here. The first thing we need to talk about is that objects can be stored in pointers. So the question is, how do we reference the members inside the pointers? Well, I kind of gave that to you in the Discord. You should have been able to figure this one out on your own, which some of you did. You can dereference the pointer and then call the dot operator. Now, unfortunately, precedence rules. The dot operator has a higher precedence than the dereference operator. So just like when you've got to put plus and minus in parentheses, you have to put the dereference in parentheses. And then you can say member. Okay? Now, people who made C++ found that they were doing that all the time, and they said, this is annoying, so I am going to make a brand new operator called this. So if we come up here, and we say the dereference, we're talking about the dereference operators. We have the star, we have the bracket, but guess what? We also have another thing, which is the arrow. The arrow operator. And the arrow operator is equivalent to exactly what I just told you. So if you need to know, the, as I said, just repeating myself here. Dereference the object member is equivalent to obj arrow member. Okay? Yeah. And your VS Code probably automatically corrects you. I saw you do that. Has that happened to some of you guys yet? If I were to come down here and say like this, I think it'll correct me. VS Code will be smart sometimes. Look, do you see that? It's like magic. It's like, I know what you meant, right? It says, I know what you meant. Now, why is it mad? Well, it's saying you're not dereferencing this. You have to dereference it before you call the dot operator. So that's why it's doing that. It says, I know what you meant. Okay, I know what you meant. So, what does this do? This is a dereference, right? This is a dereference. They're exactly the same thing. And guess what? If p pointer is null pointer, then you're going to get a seg fault. So, guess what? You have to wrap everything in an if statement. You have to wrap everything in an if statement. Man, I've been using Emacs too much. In one of my classes, I have to SSH to a parallel processing server, and everything we type is in C. So I'm using Emacs, and I've got my shortcuts all messed up here. There we go. We've prevented our seg fault. Okay? So if you are getting seg faults in your program, guess what you should do? Go find everywhere you're dereferencing something. Go find everywhere you're dereferencing something and wrap it in something, okay? Wrap it in the check. Now, here's something that will not work. It might work, but it won't always. Let's say I'm doing this. Now, for those of you that I've already helped, don't answer this. I want to see if someone else can get this. Why is this not okay? Why is this not okay? While I'm waiting, I got to do some gross human stuff. I got to blow my nose. Hold on. So, can anyone tell me why this is not okay? I am checking here, right? I'm checking. So the dereference should be okay. Klaus is right. Right. And Pig, you're also right. But Klaus is the thing here. Klaus has got it. Is that, guess what your compiler might do? Now, I'm speaking from experience, so if you want to go reference the G++ compiler and tell me that I'm wrong, feel free, but I don't trust it, okay? I don't trust the compiler. This will not always work. Why? Because x plus y, as far as the compiler is concerned, is equal to y plus x. You can swap them. There's some logic property there, right? So if you take B and C, the compiler says, hey, C and B is an equivalent statement. So there's no way you can guarantee that this happens before this does. The precedence is the same in some sense. So you need to ensure, you need to force the compiler to do this one first every time. Because if it happens to do this one next, if you do this one next, well, let me rephrase that. If this happens to get called first, you get the seg fault, okay? You get the seg fault. If this one goes first, you get the seg fault. So this comes up here. You say, hey, first, hey compiler, you better do this one first. Okay, if you don't, I'm going to come after you, right? Compiler, you do this one first, and then you can do that one. Okay? So hopefully that makes sense. If you've got any questions about that, please let me know. I saw we have one here. Cade says, the arrow thing still confuses me a little because I don't fully understand the dereference and well, so let's see if we can make it a little simpler for you. Let's pretend we have a struct my s, I don't know. And here you've got an int y. Okay. You've got a struct there. Now guess what? If you want to, say, take some variable x here, and you want to assign something to it, you can always say x equals 3, no problem. Now if you take a struct, my s, my s, and you can't do this, right? You can say s is equal to, say, a different my s, right? You can say my s g, and you can say s equals g. That's fine, that's fine. But what if you wanted to say, hey, I want to assign 3 to that variable in there? What do you have to do? You have to use the dot operator. You have to say s dot y is equal to 3. So now let's do equivalent pointer statement, right? Let's say we have an int x pointer, and let's say we allocated something to it. Okay, we've got an int here. If I want to assign something to it, I have to dereference the x pointer. I have to say, hey, this is equal to 3. The dereference says, let's go to this address and look inside of it. Let's say we're dealing with what is stored at the address. Okay, so if we do the equivalent statement here, my s, ms pointer equals new my s. I want to do the equivalent thing here. Is it making sense, Cade? I need to do the equivalent thing. So I can't say ms pointer dot y equals 3. Why? Because this is an address. This is a pointer. So before I do anything, I have to dereference it. I say go to the address. Go there. What do you find? Oh, it's a my s. It's a struct. And then you call the dot operator. And so, as I said, the C++ guys were like, this is super annoying. I'm so done with this. I'm not doing it anymore. We're going to make an arrow. And so the arrow just does that. Okay? So, I hope that makes sense. Now we're going to move on to our next thing, I think. We're doing okay on time. We're doing great, in fact. Now, we're going to talk about something fun. Let's make a... Yeah, you are welcome. Let's make a fun little example here. I'm going to call it bool. Is this the same person? And let's say it takes another person, P. And we are going to pass it by reference. Because we want to know if they're the same person. So this is kind of a goofy little function. But what is the function going to do? Well, I'll put it in a comment here. We're going to say, hey, compare the two people and tell me if they are the same. See, did I do this? Yeah, I did. I think it's fine. I think that needs to go up here, though. Okay, we're going to compare two people and tell me if they are the same. Right? Now, here we go. So let's pretend we're in main here. All right, we talked about some stuff. Let's kind of come down here and write some more code. I don't know. Found you. I'm just making this a program. The program doesn't make any sense, but it does something, right? Now let's pretend I'm down here and I say, hey, I'm going to get another person. We're going to deal with pointers just because I want you to practice them. P pointer 3. I'm going to say this is equal to a new person. All right? And now I want to compare them. Now, whenever I call new, I'm going to go type my delete somewhere. In terms of your assignment, the pointer is a part of the class. We're going to hopefully get to that today. But your deletes get called in the destructor. So you kind of don't have to do what I'm doing here. like I said, I'll get back to it. But you don't really have to call delete anywhere in the program aside from the destructor. And that's kind of why destructors exist, is for the deallocation part. So we'll get to that later today. But if I'm typing something sequentially here, this is a nice sequential program. For every new, I'm going to type my delete out at the bottom so I don't forget. Now I'm going to call this. I'm going to say, hey, is p pointer... Well, the first thing I'm going to do is say, hey, if p pointer 2 does not equal null pointer, and if p pointer 3 does not equal null pointer. First, let's make sure they actually have things in them. Don't want any seg faults in our program. Now we'll say, hey, is p pointer 2 the same? Is this the same person as p pointer 3? When you create a pointer without new, why don't we need delete? So chef, pointers are hard, okay? This is almost the same thing as this, in that they're both static runtime variables. So that means the compiler will handle this part for us. This pointer here has its own address. It's up here, or it's here. It's where it is. It's up here. And the compiler will worry about deallocating that for us. The only time we need a delete is if we call new to say, hey, you are now storing this value. So when it comes to a static runtime variable, the compiler does the new and delete stuff for us. You've been doing this int_i stuff since CS135. So the compiler will generate object code, and in the object code, it automatically puts stuff to say, hey, operating system, I need a new int, and hey, operating system, I'm done with this int. We're now entering the realm of dynamic variables, in which the pointer itself is not a dynamic variable, but the address stored within the pointer is a dynamic variable. So the reason this itself does not need a delete. In fact, if you do this, your program will break. Because what it's trying to do is it's trying to deallocate the address stored inside the pointer. If there's nothing stored inside of this, then your program dies. It says this is not right. But for when you call new, when you actually store something in there, then you need the delete. So does that answer your question? The pointer itself does not need a delete, but if you store something inside of it, it probably needs a delete. Okay? If we need more time on that, let's do some office hours. But let's come back down here. Can anyone tell me why this is red? How do I fix it? Let's test your pointer knowledge. Why is this red? Why is it mad at me? Why is this mad at me? Let's play Jeopardy, folks. For 500 points. Why is this mad at me? Why is it mad at me? What's going on here? Yeah, I have to dereference it, right? This takes a person type. This takes a person type. This takes a person type. It doesn't take a pointer. We have to dereference it. That's 500 points to pig. That's 500 points to pig. There you go. And Fuzzy. And Giovanni. Okay? So now it dereferences it. Cool. Cool. Alright? So now I want to tell if they're the same person. I want to tell if they're the same person. All right, so now we're kind of looking down here. Let's see. So in some sense, it's being called like this. You have person P2. Is this the same person as person P3? Now, yeah, Mail says, since you forgot the star, it would have put the address. Yeah, it would have passed what was stored there, which is an address. It's not a person. It's an address for a person. But yes, you were right. So in this sense, we're kind of checking out, is P2 the same person as P3? Does anyone have any ideas if we know how they're the same person? Now, I'm gonna get the easiest one out of the way. Let's pretend that two people can have the same ID. Let's just pretend. Let's pretend two people can have the same ID. So this is not enough, okay? This is not enough. I will not give you the points for this. If ID equals PID. Are we okay? Is the stream working? Is the stream working, folks? Okay. Cade, you get the points. They have the same address. Oh, wow, they have the same address. Yes. How do we tell if they're the same thing? If they have the same address. So if I want to get the address for P, can anyone tell me? How do I get the address for P? How do I get the address for P? You guys know this. Tell me. How do I get the address for P? How do we do it? You guys know this. Now, Giovanni, you are a little bit ahead of us. Do you know what kind of error this generates? You want to see some errors? Let's make some errors real quick. Have you ever seen this? I'm just going to do something very bad here, okay? I'll do it here. I don't care. Here and here. This is going to make some errors. Wow. This worked. This is going to make some errors. Now, let's see. Does it know why? There we go. Yeah, I'm not going to compile this. This just says, I don't know what equals is for the person class. We're going to get to operator overloading later, okay? So, no, this doesn't work. And if you think about it too, if I said int x equals 3 and int y equals 5, and then I say if x is equal to y, this checks the values, okay? This checks the values. This checks the values. I want to check if it's the exact same address. That's what I'm looking for. I want to check if this is the exact same address. Someone got it, Chef, right? We're going to have an and P. Now, you can't guess this because I haven't taught you yet, but P2 is assumed in here, right? You guys understand that if I see out ID here, I see out the ID here, and I see out the p.id here, you guys understand that this ID belongs to, in the case of this example up here, this ID belongs to P2, and this PID belongs to the P3, right? I think we talked about this in class. You guys understand that, right? That this ID is corresponding to P2, and this ID here is corresponding to the parameter. So please tell me if you understand that. I think you should. Now, how do I check the address of this thing? Well, we have this. What is that? Well, let's go to our notes and let's make some notes, shall we? This, the this keyword. Now, I know some of you, I've already talked to you about this. Synthos says, where's P2 declared again? This is hypothetical, Synthos. This is hypothetical. This is some hypothetical. This is hypothetical code. Okay, I'm not trying to be syntactically correct. I'm just making an example. If this makes you feel better, I will do it this way. Okay. P2 was not declared anywhere. It's just a hypothetical example. Okay. And I want you to associate that this ID belongs to P2 and that this ID here belongs to P3. That's all. So hopefully that clears it up. So the this keyword can only be used inside a class. This is a pointer to the object. This is a test question, okay? This is a test question. And we do have a test coming up, by the way, not to scare you. I'll talk about it on Thursday. I won't throw it at you. It's not on Thursday. And I won't host it next Tuesday either, but it may be next Thursday. I'll talk about it on Thursday. Just be aware of that. I said it. I just remind myself. I'll kind of add that at the notes at the end of class today. Anyway, this is a test question here, okay? Remember this. This is a pointer to the object that the member function was called from. I'll talk about it on Thursday. All the test questions will come in here now. I'll talk about it on Thursday. First thing Thursday, I'll talk about it. This is a pointer to the object that the member function was called from. This is the best way I can explain this. This is a pointer to the object that the member function was called from. So let's kind of do some example here. Check it out. Check it out. See out this. See out the address of P. We'll say, hey, see out same object. This is the same object here. All right, this is the same object. They're the same thing. This member function called this. Yeah. The this object. It's hard English. It's hard English. Okay, it's hard English. But you need to understand what I'm talking about here. The this object. The this object. So let's run this code. Let's give it some testing here. We're gonna call it here. All right, we're gonna call it here. Let's see what we get. We're almost done with class here, guys. So hang with me for 5 minutes. Hang with me here. What did I do here? Excuse me. Int main, get person, get ID, pointer, I declare this, I check if they're both not null pointer, which they shouldn't be, right? And so then I should call this, right? And when I call it, I should see some couts. Excuse me, Bobby, but I need you to work. I'm running into some errors here. What's going on? What's going on here? Let me get rid of these. Is there a return 0 somewhere? Perhaps. Probably not this one. Maybe if p pointer 2 does not equal null pointer and p pointer 3 does not equal null pointer. P pointer 3 definitely does not equal null pointer. And p pointer 2 definitely should not equal null pointer. Let me see here. Oh, look. Guys. I'm terrible. There we go. Okay, look at this. Look at this. Look. So look, these are their IDs. And then, look, their addresses are different. But what am I telling you here? I'm telling you that this is an address. I'm telling you that this is an address. Okay? So if I want to check the same person, look at this. This is fun. If I check p-pointer2 with a dereferenced version of p-pointer2, they are the same. They're the exact same object. Now I'm about to blow your mind, all right? Same object. They're the same object because they're stored at the same address. Now check this out. When I'm in the class, like I said, how do I know that I'm referencing this object? Yeah, aliases. Yeah. You're kind of right, but it is passed by reference. So I'm literally passing the same thing to it. I wouldn't call it an alias, but almost, yeah. But Chef gets it, right? How do I know what this is talking about? Well, this is assumed. This is assumed. Is your mind blown yet? So look, I am calling a dot operator here. What does this ID belong to? It belongs to the this object. What about this ID? Who does it belong to? It belongs to P. Are you as excited as I am right now to know this? Do you understand what happened? You can dereference this, and you can call the dot operator, and you can reference whatever is stored here. This is the same thing that you've been doing this whole time. You guys probably are not as excited as I am. But that's fine. That's fine. I'm not worried about it. Okay? So, that's our talk for today, all right? We kind of talked about, we just got familiar with these objects. Klaus asks, why do we deref that but not P? Well, P is passed in as a parameter. And if this was a pointer, then we'd dereference it, but it's not passed as a pointer. That's why. This is always an address, all right? It's always an address. So, that's our class today, okay? As I said, we talked about this, we talked about our arrow, and we talked about some assignment stuff, right? Working with objects, all right? This was all on schedule, right? We should have talked about this stuff maybe a little earlier, but you should be able to do your assignment for sure now, all right? So get started on that. Nicholas asks, is this used in our assignment? No, it's not. You don't have to use this in your assignment. So whatever is passed through is referred to as this. Mail, just always reference this. This is a pointer to the object that the member function was called from. So here, I call it from p-pointer2, meaning that this is referencing this object. Okay? I'm gonna revisit assignment 4, okay? Please work on it. I'm just gonna maybe change the code grade up a little bit. I'll see if anyone got a 10 out of 10 on it, and if they did, then I won't bug them. But I am going to visit assignment 4 just a little bit to fix that rotation function so that it matches the PDF. That's really it. On Thursday, we'll talk about the test, and we'll talk about double pointers and arrays and stuff, okay? So that is Thursday. If there's any questions, please ask them. You're free to go. All right. Thanks for coming today. I'll see you guys next time. All right. Hope you learned something today. I always have a great time talking to you. Thanks for participating as always. It's my favorite part of the day. Yeah. Cade, you're welcome. Have a great day. Top Wolf, you're welcome. Have a good day. Fuzzy, you have a nice day. I will hydrate. Kane, you're welcome. Uchi, you're welcome. Synthos, you're welcome. Pig, you're welcome. Nick, you are welcome. YCS, you're welcome. Giovanni, you are welcome. Oyman, you are welcome. Young, you are welcome. Klaus, you're welcome. Chef, you have a great day. Turbo, have a good day. Thank you. You're welcome. CS202 student, you are welcome. I'll see you guys all next time.